Response video for Veritasium video for the four riddles, revolutionary riddles. For the first riddle, you will have to fill the cylinder with water or any viscous fluid such that when the cylinder moves downwards, the liquid will move backwards the cylinder. So, if this is the center of rotation and this is the contact point, in normal case, the center of gravity will be at the center of the cylinder, will be like this. So this distance will cause a torque in this direction and will move the cylinder downwards. But when there is a viscous fluid inside the cylinder, it will be like this, moving the center of gravity from this point to this point, about this point, causing it to move behind, fall behind the center of rotation, and causing a torque in this direction against the direction of rotation, and causing a negative angular acceleration, and will cause the cylinder to stop. When it stops, the liquid will move again to its normal state, like this, about like this, and this will move the center of gravity again to the right of the center of rotation, and will cause it to continue to move down the inclined surface. For the second riddle, we will approximate the bicycle by a wheel. The wheel have a pedal like this, and will affect the pedal by a force in this direction. So this direction will be the forward direction, and this direction will be the backward direction. We will know now in which direction it will move. So we will move this force to the center of the wheel, and we will substitute this moving by a torque in this direction to substitute the effect of the force trying to move the wheel in this direction. So this will be the problem. We moved the force and substituted this movement by a torque. This torque equals to, if the pedal length is r, this torque will equal to Fr small. By studying this wheel, we will find that this point, which is the center of rotation, has a zero velocity relative to the ground, which is from mechanics, the no-slip condition, and this means that we can take it as a reference point for the moments. So if we took the summation of moments about this point, assuming that this is the positive direction, we'll find that the force is trying to create a moment equals to the force multiplied by the radius, which we'll notate as R capital, the radius of this torque, which equals to the force multiplied by radius. As we know, the radius of the wheel is bigger than the radius of the pedal, so this means that it will have a positive moment in this direction, so it will move in backward direction. For the third riddle, we know that the velocity equals to the distance divided by the time. For the first lap, the velocity v1 equals to the distance, which is the track distance, divided by the time of the first lap. For the average velocity of the two laps, v average equals to the distance of the two laps, which is 2d, divided by the total time of the two laps. And as we conditioned, the v average must equal to v1. From this, we can substitute v1. We get 2d over t1. By comparing these two, we notice that t total equal t1. This means that we have to move by infinite velocity to finish the second lap in no time, and make the total time equal to the first lap time. so the velocity of the second limb must be input. For the fourth riddle, which is pretty simple, we will apply what we did in the second riddle. We will find that the rails is like this, and the wheel of the train has two parts. The part which slides on the rails, and another part which keeps the rails from moving outward the rails, like this. This is this part, and another part like this, preventing. So from this figure, we notice that this is the center of rotation, and any point below this center of rotation have a velocity in this direction, but any point upward the center of rotation have a velocity in this direction. So the smallest, this small part will have a negative velocity. That means that it will move backward while the train moves forward.